congruent polygons. To have two congruent polygons, all of the corresponding angles and all the corresponding sides have to be congruent. We're going to take this statement here and identify all pairs of congruent corresponding parts, and then we'll write another congruent statement. I'll show you what that means to write another one. It doesn't mean to rewrite this one. So here we have our two figures, and you should be able to do this even if you don't have the figures. But the book, they do give you the figures when you have to work these problems. So you have, by the way, what kind of polygon do we have here? It's a pentagon. No, wait. It looks like a pentagon. How many sides does a pentagon have? And how many sides does this have? 4. But it looks like 5, doesn't it, at first glance? But it's not. Thank goodness, because it does to me, or it did to me, and to her. I didn't look at it good enough. But thank goodness it only has 4, because we're having to name all of the corresponding parts, and it would be just that much more to name. Okay, so if I wanted to name all of the corresponding angles, and I didn't have this to look at, I could look at this statement and match up the angles. Angle G, let's write this in red. Let's see. Angle G is congruent to which angle? Well, you can look at the figure and it would be Q, or you could look at the statement and it would be Q. It's in the same location. The order matters. Yes.
Are you recording?
Yes.
She did that last time too. I'm sorry.
It's okay.
Hey, it's for your number.
And angle H is congruent to, so G and Q, then H and R. And you can look at the figure as we do this to see how that works out. Angle J is congruent to angle S. Angle K is congruent to T. Okay? So that's all the angles, but then we have to name the corresponding sides. So the angles are a little bit easier because you only are worried about one letter. For the sides, it takes 2 to name the sides. So we'll start with side GH. Use the segment symbol. It's congruent to side QR. Next would be HJ, and you can follow along on the figures to see how that works. JK, and I'm being serious here. Don't get it. ST. The older you get, the more you appreciate corny jokes. All right. What about the last one? The first 3 are pretty easy because GH, HJ, JK, well then, what's the last side? How do you name that last side? Because there are 4. KG or GK. It doesn't matter what order, but, so you said KG? All right. It's congruent to TQ. If you have a hard time following just this part, look at a figure. Draw a figure if you don't have a figure. But I think you'll, it looks like they're going to get, the old book does not give you a figure. You have to do all of this. The point of doing this is, 1, to understand that all the corresponding parts have to be congruent, and 2, to understand that these letters have to line up correctly. If I switch R and S, this would be wrong. Whatever order you start out with on the first figure, the second figure, the letters have to match up by congruence when you're making a congruent statement. So on this last part, then write another congruent statement. So GHJK is congruent to QRST. Well, let's put this one in a different order. Instead of starting with G, we could either go backwards or we could start with, let's just start with J. We can say that JKGH is congruent, because it wants another statement that's a congruent statement. Well, if I start there, I can look up here and see which matches up with J and which matches up with K, or I could come over here, J, K, that will be S, T, Q, R, right? And the same things still match up if you look at all this other stuff. Okay, so that would be your answer. These properties are in your book. If you can write it all down if you want to, or if you just want to write down reflexive, symmetric, and transitive. I think we've used them enough for you to understand what they are. The reason we have them again is because it's talking about the reflexive, symmetric, and transitive properties of triangle congruence. We've already talked about congruence. Well, it's the same thing. So when one triangle is congruent to itself, which seems like, why do we even have to say that? But you'll see, is a reflexive property. If this triangle is congruent to this triangle, then you can switch the statements around and they're still congruent. So just, it's almost like, I mean, you're just switching sides. Transitive seems more important, seems more useful, even though they're all just as useful. Transitive property, if this triangle is congruent to this triangle, and this triangle is congruent to some other triangle, then that first triangle is also congruent to that triangle. Transitive property. Yes, we will be doing proofs again.
How
I thought you would clap and say, yay, they're fun. Come on, it helps you think logically. All right. If you don't have all this written down, you can get it out of your book. It is on page, you can write this page number down. It's on page 241. So I'm going to go ahead and go since we are running out of time. Third angle theorem. Let's say you have two congruent triangles and you know the measures of two corresponding angles, two pairs of corresponding angles. What can we say about that third pair? I actually should be covering this up so you don't know the answer. What can we say about that third pair of angles? They're congruent, and why? Let's look at the figure and see why is that true. So if we look at these two, and they're both 95 degrees, and these two are both 25, how do we know that these two are congruent to each other? Well, the sum of the interior angles of a triangle is, because we learned yesterday, 180. And if I subtract these two from 180, whatever answer I get, I'll get the same answer over here, right? So that's why that works. So let's see. Is it 60? Wait. 20. Is this 120?
Yeah.
So this would be 60 degrees, and this would be 60 degrees if I did the math over there. That is also in your book if you don't have it all written down on the next page, 242, this theorem. And this video will be available, the notes will also be available online. So let's do some problems here. I need you to open your book because I don't have the figure up here. I must have accidentally deleted them. Page 243. On page 243, number 6. What is the measure of angle M? I'm probably going to have to put them up here and we're going to run out of time. measure of this angle?
Which one?
This one. For number 6. All right. There's a reason the statement is up here. It's very important. 1, we have to know that they're congruent to each other. 2, we have to know which parts are congruent to each other, which is why we did what we did a minute ago, where we were identifying the congruent parts. If you look at M here in this statement, you can look and see which one matches.
33.
So it's 33 degrees. See, these look alike. It's hard to know, does this angle go with this one or this one? It's pretty obvious it doesn't go with that one, but the other two look so similar. You have to look at the congruent statement to see what matches up with M. What about XY? Let's see, XY is congruent to MN, and MN is 8, so this would be 8. Right? Find X and Y. First I want to find X, and I see that I've got 2X minus 50 over there, and then I have 2X minus Y. I don't want to do 2X minus Y. I want to do the 2X minus 50 because I can set it equal to something. And it is equal to, let's see, U and N are congruent. And I can find the measure of angle N by subtract. So the measure of angle N plus 142 plus 24 is equal to 180. So the measure of angle N plus 166 is equal to 180. The measure of angle N when you subtract 166 from both sides is 14. So 2x minus 50 has to be equal to 14. So add 50 to both sides. 2x equals 64. Divide both sides by 2, and x is equal to 32. Now we have to find y. So that's the first part. To find y, we have 2 times x minus y, and well, we know what x is. It's 32. And that is equal to, well, NP is equal to SU, or US, which is 13. So that's 64 minus y is equal to 13. Negative y is equal to, you subtract 64 from both sides, and that would be 51. Negative 51. Divide both sides by negative 1, and y equals 51. Show that the polygons are congruent. Explain your reasoning. So the book wants you to show already what's given in the diagram, but I don't care if you repeat showing that x, y is congruent to y, z, and all that stuff. But what you do need to show is what I'm about to mark in blue. Well, in order for these two triangles to be congruent, all corresponding sides and angles have to be congruent. Well, let's start with this side. We know that there's 2 pairs of corresponding sides that are congruent, but what about this third pair? Well, they share that side. And we have to show that YW is congruent to YW. That seems crazy because we know that something's congruent to itself, but we have to show that because it's to 2 different triangles. And the reason that we know that is by the reflexive property. Okay, and then we know that these two are congruent to each other. Since this line is parallel to this line, we have parallel lines cut by transversal, and those are alternate interior angles. So we know that angle XYW is congruent to angle YWZ by alternate interior angles are congruent when lines are parallel. Then we know that these two angles are congruent by the same reason. So we can either say third angle theorem because they are congruent by third angle theorem, or we can use the parallel lines thing. But I'm just going to use third angle theorem. Angle ZYW is congruent to angle XWY by third angle theorem. So therefore, triangle XYW is congruent to triangle ZWY because all corresponding parts are congruent. And there's your assignments.